Today, what we are going to do is to show you the technology of Bpro. They will be divided into three sections. The first section will be talking about the principle of applanation tonometry. How the algorithm enables us to derive the data that we are able to show. How we are enabled to allow this technology to be licensed out to people who are interested. Applanation tonometry is not new. It is something that has been used for more than 30 years. What is applanation tonometry? Basically, it employs the principle of this. The moment we have a sensor, which is a pressure sensor, that we press against an artery that is fully pulsating, and when the sensor presses on the artery and flattens it a little bit, what then happens is that the center intraluminal pressure, or the pressure that is inside the vessel, as it pulsates, it will be transmitted to the sensor and be recorded. But for applanation to be effective, a few criteria is very important. It's near the surface, it's against the bone, it doesn't change its position, and the most important thing of all, it is an artery that is hardly affected by atherosclerosis. As it pulsates, the pressure inside is called the intraluminal pressure. It pushes the wall of the artery outwards. But the arterial wall has muscle and it actually squeezes the shape back. So as it pulsates, it's been squeezed back. The force that is pushing it out, we call it P1, will then be equal to P2 when it comes back. Applanation works when the artery is partially flattened. As it's partially flattened, we actually obliterate P2. We have lost the circumferential force. So the full force of the pressure inside the artery is fully transmitted upwards to the sensor. We have big devices that you cannot carry around, and you got to strap the arm up and you got to actually tie the patient down so that you can actually perform an applanation. Our device need to overcome this. Now we must enable this device to be worn on the wrist, to be portable, and yet allow applanation to take place. And there comes the technology of Bpro. You will see that the applanation is actually occurring at the sensor housing. So there are a few parts which you must notice, which is the sensor housing, which has a little plunger. We have a watch head. This contains the board of all the signal that can be stored inside. Between the head and the sensor housing, there is a flexi cable that connects and transmits all the data to the head. But the most important thing is not in this tool. It is in the strap. This patented strap has an elastic strap just above the sensor. It's to provide an applanation force. So that when you wear the watch around the wrist, it presses down and flattens the artery through the plunger. The second thing about the strap is that it's freely sliding. When you wear the watch and the wrist move, the movement of the wrist is actually bypassed by this freely sliding strap. So this freely sliding strap with the elasticity provides compression and therefore applanation for the radial artery. But that's not all. If you strap somebody's hand up and you put them for more than an hour, the biggest problem will be blood flow. You literally shut down the veins and the veins cannot return blood to the body. And you actually have a swollen hand at the end, which is no good. To illustrate what I mean, let me put the watch on. You will see. This is the sensor housing. The white line corresponds to the center of the plunger, which is a hemispherical piece. And this will be resting on the radial artery. With this white line, wearing the watch is very simple. Imagine an outer line here and the midline of the wrist. You draw a midline between these two lines. That is where you put the white line. That's how you put, and you will actually capture the radial artery. And then you slip this watch and secure with a Velcro strap. When you wear this watch, you'll find that there are actually 4 triangles. The triangles are specifically designed to be at this position, and over at the sensor side, this position, and this position. So there are actually 4 triangles that allow blood to flow back from the veins, and that prevents compression of the vein. And therefore, what you get is a very faithful recording without compression of nerve and artery, to make the position even more stable and fixed. You will notice that there is a special padding, a biocompatibility pad. Any other blood pressure monitoring device, you take the blood pressure here. The difference is, after taking the blood pressure here, the data is then entered into the waveform, and you actually calibrate the waveform. We can calculate through our algorithm, as new waveforms come in, how much does the blood pressure go up or come down, as evidenced by the application tonometry that have been proven many years. We are able to track the blood pressure closely. So Bpro Soft, when you download this data, the data we process to produce systolic, diastolic, mean arterial pressure, heart rate, and the heart rate, to note, is actually the heart rate calculated from a single waveform beat. It is not a collection of heartbeat multiplied by a certain number to give you a 1 minute beat. It is the actual heartbeat of one best fitting single waveform in that block. So it is really a beat to beat recording. Now these data are then plotted onto a 24-hour chart, which gives you the way blood pressure fluctuates. The central aortic pressure can be derived from the waveform by using our 2 patented technology in our formula, whereby we use a formula called N/4 moving average. N equals to the sampling time or sampling rate. If you are sampling at 60 Hertz, you'll be 60 divided by 4, which is 15. And you do an average moving 15 point to draw a second curve, and the peak of that corresponds to central aortic pressure. Bpro software is a software you install in your computer. You will see real time, and it will actually present to you data like central aortic pressure, our index for augmentation, our augmented radial pressure, and many other indices that tells you the stiffness of the artery. Now all these devices are not, or the software, as I said, are not just numbers that we came up with. They have clinical implication. For example, the 24-hour blood pressure. We know that the pattern actually determines the risk of stroke. The central aortic pressure is the strongest indicator in terms of BP, whether a person gets a stroke, a heart attack, or how he will survive. And all these have been validated. The 24-hour blood pressure Bpro Soft has gone through the American standard, which is AAMI, the European standard, which is ESH protocol, and on top of that, we actually did a 24-hour comparison with Space Lab 24-hour machine and us, point for point. And what we got was such a close relationship that we got our FDA in 60 days. Bpro Solve is now listed in BHS website as a recommended ABPM. The important thing is it does not cuff the patient, and therefore you're not disturbing the sleep. A-Pulse, on the other hand, we have a central aortic pressure which has been validated invasively by an interventional cardiac surgeon to actually pass a Miller's catheter up to the aorta, and we actually capture the waveform and the central aortic pressure wave for wave with the watch on the other hand. The correlation is a 0.9917, and we got the FDA approval in 45 days. Both these devices are now used in major clinical trials around the world. HealthStats have just developed a home monitor, and it's actually called Caspel. Caspel is an all-in-one consumer-used central pressure monitor. It is the world first. It's a very simple to use, one button press operation. These devices have been well validated. It is a device that allows the high-tech frontier technology to be brought to the man in the street so that you and I can benefit. That is the really driving force behind the technology of Bpro and HealthStats.